showing some of the keyword searching to you. So right in the homepage of SciFinder, there is a big search box right here. So you can type in anything you want. You can start from substance name, or you can start from any keywords, or you can even type in sentences or questions of your interest. So today I'll be doing which flowering plants contain antibacterial phenolic compounds. So this would be my question. I'll press search and we'll have a look at how the results come out. So depending on the type of keywords you type in, you will see whether the results come out under all substances, reactions, references, suppliers, or pattern markers. So it looks like because now the SciFinder engine has recognized the question as being it includes some of the substances information and maybe references as well. So it is now under all. But just underneath all, you can see that there is AI summary. So depending on what we get for the reference results, you'll see how the AI summarization gives you by clicking on view all. So here, the AI summary includes the summary of the top 20 most relevant references that comes out as the results. As you scroll down, you can see there are references searching and substances searching as well. So I am going to go straight into more reference results by clicking on view all references, or you can go to references right at the top, just underneath the results for the question I typed in. So now you can see that there are 44 results. AI summary again exists just underneath, and you can click on view all to take a look at additional information that is provided by the AI summarization engine that SciFinder has. So there are key findings, all in orders, number 1, number 2. And what's good about AI summary is that SciFinder actually does give you the references that are related to each key finding. So where this comes out is actually from the first reference, and then the second point came out from the 5. But you have to remember that AI summary only comes out when the reference is sorted by relevance. So only the top 20 most relevant references are used to generate the AI summary. So let's go down a little bit more, and you can see that the keyword has been highlighted. Going back to the top, just under the reference search for the question I typed in, there is query interpretation. So you might question, then how is my question has been interpreted? So by clicking on query interpretation, you'll see how it's been interpreted. And if you feel that the 44 results isn't enough, I think this is quite a small number of references that I get. So if you click on search original query, then you will get additional references that come out from the actual questions or keywords that I typed in the original search type. But I think this is a bit too many, but we can use the filters on the left to narrow down the results. So before we narrow down the results, I want you to take a look at the analyzed results on the right-hand side. So the results here on the right, it's actually the analysis of what has been retrieved. So the top number 1 is the top document types. So it looks like there are more journals than patents that has been searched. And if you prefer, you can change the bar chart to a different type of chart, or you can go back to tree map. Clicking on this expand chart button, you can see a bigger picture. And again, you can download it or change to a horizontal bar chart. And scroll down, there are patterns. So a lot of them are also from patterns as well. So depending on which area of the world you want this pattern to be from, then you can click on any of this countries to narrow down the results to the actual countries. And then the substance roles, publications over time, and looks like if you look at the graph, the number of references over time has been increasing significantly. So you can kind of tell that this area is quite a very well known. It's been researched quite a lot recently. IPC codes, authors, and assignees as well. So these are some of the analysis that you can use to analyze the overall results that you get. But if you don't want to see it, there's an option for you to close this by clicking on X, or you can click on Analyze Results. So let's get rid of the results on the right. And I think this is a bit too many, so I want to narrow down a little bit. Before we narrow down, there are two options of filters. So if you want to narrow down by clicking on some of the things that are available in the filters, you can use the filter by. But if you want to exclude something from your answer set, you can click on the exclude behavior to remove certain set of answer sets. I'm going to be using filter by first, and I want to look at the most recent, maybe the recent 10 years of the documents. So scrolling down to publication year and then typing in 2015 as my minimum and click apply. And now we're down to 668,000 results. I think this is still quite a lot. So I'm going to narrow down to only the journals, document type journal. Still quite a lot. So I'm going to be using some other filters to narrow down the results. But before we do the filters, I want you to take a look at some of the informations and details of the documents. So let's have a look at the third document before we go into some of more filters. So pressing on Control button and then clicking on any of these buttons will open up a new tab, or you can right click and click Open Link in New Tab or New Window to take a look at these details in a different tab. So I have opened this third document in a new tab. So you can see that there are things that have been highlighted in blue, meaning these words have been typed in the search box and have been retrieved. So flowering, flower, etc., etc. And if just under the keywords, if this button open access is available, that means this document is an open access journal. So anybody would be able to open this journal. And have a look at the downloads, and then you can see the PDF of this full text. Going back to the detail page, there's publication information. It's a journal, and it was published in 2020, as you can see on the left. And then the company or organization or school is listed down here. And scrolling down a little bit, you can see there's similar references that has been done by SciFinder. So there are additional references that are maybe similar to this specific document that we're looking at. Clicking on CAS concepts, there are some keywords and some would have highlights too. So I think CAS concepts is a very important thing that you should probably remember from SciFinder training today. So CAS concepts are basically the standardized keywords that have been extracted from this document, but not necessarily these keywords are directly from, these keywords are not sometimes used by the author itself. So these are the standardized terms that CAS use so that users like you, students, professors, or any researchers can use to filter down the references later on as well. So these are the concepts that you can probably have a look and see, okay, this document was talking about flowering, growth and development, and some of the plant genes, or it also talked about signal transduction, any specific plant genes and flower buds, magnolia, and etc. So by just looking at these concepts, you understand what this document is really talking about before going into the full text. Down here, there is additional Medline medical subject headings. These are also under the concept information in the filter. You can use this to filter down the references. Substances as well. So depending on how many substances are mentioned in the document, you'll see different numbers of substances. But in this particular document, there were 2 substances that were mentioned. Number 1 is this, phenylpropanol. Number 2 is this compound. Each compound have structures and CAS registry numbers. So CAS registry number is actually the number that is provided to every known compound, and this number is being registered and it's still being controlled by CAS here, our company. So we have the highest number of and most comprehensive collection of compounds around the world. Down here, there are cited documents. So if you're interested in additional citations of this document, there are a list of things here. But at the top of this page, there's also the citation map that maps out most relevant additional documents that are related to this document. So I'll take a look at this by clicking on citation map. Again, it opens up a new tab without using the control button or doing the right click. So here you can see that the title is one we have selected earlier on. And in this diagram, you can see that right in the middle, this document, this book represents my selected document. And the ones on the left in purple are what's called cited by. So these are the references that have been cited by my selected document. And again, if you look at the legend, these are cited by root documents. And then on the right in green are the references citing my selected document. So these 2 are slightly different. And on the left-hand side, there is also filters. You can filter by document types, flags, concepts that are still available in the previous page. By clicking on cited by, which are the purple ones, purple dots, and you can see that the color changes. The top document is actually the darkest purple. And then if you scroll down, the purple color actually lightens up. So what it means is the darker the color, the more cited the document is. So the top at the top of the page, this document has the highest citation of all of these references. Again, going to citing, the color changes, but you can kind of tell that the darkest green isn't as dark as the purple. That means it's this document is pretty new, and so these new references citing root documents are pretty new as well. So it's not that much cited yet. So the color means that. And as you can see, if you click or if you hover over any of these dots, you can see the title of this document and you can click on expand citations. So if you're interested in additional citation information, then you can click on this and you can expand it backwards. And you can do that again by clicking on expand citations. But you will notice there will be some documents that has no citation button available. That means it's just not, the citation information is not available yet, or it's not going to be available because it's still a very old document, but the citation information wasn't just available for this document. Again, forward is possible, expand citations, and again, it's possible for additional info. So not just one root document is there. You can have a look at additional references that have been cited, or it's citing the root documents. So that's that. Go back to the main document page. So we've looked at the title, concept, substances, cited documents. And if you think that this document is important and you want to save it, there are mainly two types of saving. So there is download detailed information. Clicking on this button, you can download the reference detail as an Excel or citation, PDF, text file, RTF, etc. You can choose the fields. If you want this abstract, you can add them. If you want the substances info, you can add them information. So all these fields are available for you to choose. If you click download, it will be downloaded as an Excel file. And you can change the file name if you like. An additional thing would be to add to your project, or also to save it in SciFinder for your reference later. So you can click on save results, or you can share results with your friends or your professor or anyone who has SciFinder access. And then you can click search, or you can save results. And then this will be later saved in the menu, under the menu and saved option here. So you can have a look at them later. Okay, let's go back to the actual search results. So we've looked at the concepts. The concept filter is available. So let's click on concept. And out of all these documents, I am interested in certain things. So clicking on view all, not only we see these top 5 concepts, we have additional information. Let's say that I am interested in maybe some of the analysis information of these compounds, or I want to look at how these compounds have been extracted from certain flowers or plants. So I think it'll be a good idea to narrow down the searches that have those maybe extraction or analysis concept terms. So it'll be difficult to find those specific terms on the top count. You can either go to alphanumeric, or you can actually do the search. So I said I'm interested in extraction. So instead of putting extraction, I am going to just add extract and use this wildcard star sign. So what it does is it expands the term on the right-hand side. So it will search for extract, extraction, extracting, extracted, or anything that contains extract as a starting word. So it's a long list. You can see that there's extraction, extracts, or maybe there'll be more, but it looks like extractive and all other things. Extractive wastewater treatment, blah, blah, blah. So you can use this wildcard to expand the word on the right-hand side. Okay, so I think I'll be quite general and just click on extractants, extraction, and maybe add natural product as for another concept. There's a lot of natural product concepts, but by looking at these number means the number of references that are connected to this specific concept. So maybe I'll look at that are maybe those that have high number. I think I've seen pharmaceutical natural products, new natural products. I think that will do, or even natural products as well. So overall, I've selected 5. When I'm done, click apply. Then now the reference narrows down to 21,000 results with all the filters I have selected at the top. Okay. And again, this time I'm quite interested in not looking at certain keywords. So again, I'm going to change the behavior to exclude. I'll be using search within results. So in my results, here we have 21,000 results. I do not want antifungal as my keyword to be included in my answer set. So search within results, antifungal, or if you want to add additional keywords, you can type in antifungal or anything that you don't want to see in your answer set. But today I'll be just be doing antifungal and click search. Didn't have that many, it looks like. So sorry, I think it's not been done. Because then you will have to see it under the filter. Let's have a look if it works again. Okay, so now it's gone down to 18.5-ish thousand. So you can see that there's what has been included, what has been filtered, what has been excluded. So that's what you can kind of do just by doing all these filters. You can start very big, and then you can narrow down to additional by using all these filters on the left. Okay. I do want to take a look at additional search types. So I'm going to go back to the main page. So clicking on the home page, home button, you can go back to the main page. So let's consider that by looking at all these documents, and I think I want to focus just on specific scientific name of a compound or plant, then you can just type in that as well. So I have a list and I have a name. So this will be something I want to focus on. So I have typed it in, click search, and see what comes out for references. So it looks like even though I typed in just one search, it recognized it as reference. So you can have a look at 34 results that came out. Should we have a look at the second one? So if you click on this title, you can see that this has been highlighted again, and this document specifically has the picture, the structures, etc. So down here, serious concepts, supplementary concepts, substances, but on top of that, you have additional information for this. So if you click on pharmacological data, that means you have additional life sciences information. So depending on the ligands and then the target, function, parameter, value, and disease, you have the bioassay information and what the target is, function is, what the value was. So for some of the documents that includes the pharmacological data and toxicity information, you should be able to find it under this document information. And again, you can download this information by clicking on this button. So it's been downloaded and it's done. You should be able to find this. Okay, let's go back to the main page again. So we've looked at AI summarization and some of the query interpretation, but other than that, you can type in more things and it will just show you what happens. So this time I am interested in specific compounds, but not just the compound itself. I want to look at its proton NMR of specific compound. Then what you can do is just type in proton NMR of catechin, for example, as my compound name. You don't have to go into a substance information to find the spectra. Instead, if you type in proton NMR of certain compound name or CAS registry number or anything like this, anything that identifies the compound, you will see its spectra if it is available in SciFinder. So you can take a look at this, and mostly it'll be experimental. And on the right-hand side, there is proton NMR spectrum information with the working frequency, solvent, spectrum, and then the peak data, etc., and then the source info. Down here, it will not just show the spectra, but if you're interested in looking at additional information like substances information, properties, references, it's all there. And again, if you're interested in other properties of the same compound, then you can do this as well. So I'm interested in melting point of catechin, but instead of typing in a substance name, you can type in compound's CAS registry number if you know it. So you can put the CAS registry number. And the melting point just shows up on the top, at the top of the page. So you don't have to go into substance information. But sometimes you'll see, just like here, you'll see there are more melting point properties and values available. So it will really depend on the condition and how it's been measured in different reference sources. So for every value, you will get the source information on the right. So you also have the access to the journal information or even patents. And you can take a look at view in detail page. Take a look at melting point and additional substance information. Let's have a look at additional information of this specific compound. So by clicking on this number, which is CAS registry number, it takes you to the detail page. It looks like my internet's slightly slow, but maybe we should wait just a little more. Otherwise, we'll let it run and then we'll do another search and come back to the melting point part, the substance information part. Okay, so we've been using this mostly, and especially for the substance as well. And then the substance name and then etc. But a lot of you might have already been using the draw button on the right hand side. So draw button on the right gives you this pop-up of a drawing page where you can draw the chemical structure. And right at the top, you can enter a systematic name or CAS registry number, SMILES or INCHI, to bring about the structure directly. So for example, what systematic name is basically any names, the chemical names that probably includes IUPAC name or that represents the structure part of the compound, then it will just generate the structure for you. So for example, 1,2-dibromoethane, it just draws a structure for you. And if you know a CAS registry number of a compound, like earlier on, and it just draws us the structure for you. And then you can move around the structure or even add the structures and then delete them. So you can do any type of a search here. I'm going to clear this by clicking on new on the left-hand side, this button. I do not want anything, so dismiss and clear. And I am going to be drawing a compound. So this compound is actually, oops, a random compound that I created. I'm not sure if this compound exists, but I am going to be checking this. So this and nitrogen, and then the 5-membered ring, and the benzene ring, and this pencil. Clicking on the single bond would making it into a double bond. And by putting the mouse on any of the nodes and then just press nitrogen N or O, it just changes the node to each element. And that shortcut is available here with the question mark. Keyboard shortcut is here. So while hovering on an atomic node, if you press N, it changes to a nitrogen. Shift N, it changes to sodium, blah, blah, blah. So all these shortcuts are available. And I want to see if this oxygen and then a methyl group, this compound exists. And note that I did not draw hydrogen on this nitrogen, on this nitrogen, and this nitrogen as well. So what it means is I am just opening these nodes so that I'm allowing any substitutions on these positions. So if you want to make sure that this nitrogen ends with 2 hydrogens, then you can draw 2 hydrogens like this. Or there's also an option for you to use the shortcut menu on the left-hand side with an ET, ethyl group. There is NH2, so you can change that to an NH2, and maybe you will have to delete these 2 hydrogens that I just drew. And again, same thing, NH or NH, but I'm going to leave it open just like this without hydrogen so that there are more substitutions available. Okay, so when you're done drawing the structure, click OK on the bottom and click search button to see what the CAS registry number is if this compound exists. Okay, so when I do the structure search, you will see on the left-hand side, the results will come out with 3 different answer sets. Structure match being as drawn. Number 2 is substructure, and then the similarity. So it looks like there is 0 as drawn structures, meaning there is no exactly the same structure as I drew. So there's nothing that has exact structure as mine, but there are 5 substructures, meaning these 5 compounds include the structure that I drew, but has additional substituents. So for example, the first one that came out includes the structure that I had drawn in the paper in this CAS drawer, but has additional O and CH3 bond here. And this one also has the same structure, but has a methyl group on this nitrogen. This one, same, but has carboxylic acids, ester group. And this one actually is a ring instead of a chain. So you can see that substructure results is basically anything that has the structure as part of your answer set will come out as this. If you click on similarity, usually similarity results are bigger, a lot bigger than as drawn or substructure. So it looks at the actual similarity of the structure to the repository of CAS registry number compounds in CAS. So it looks like there are 929 K substances, but there are here 1,022. That is because you can choose the similarity scores. So the 99 plus and down to 89, 85 has been selected, but you can expand it by clicking on additional numbers down here Obviously, low numbers would have more compounds, but I think it's okay to keep it as this. And then if you want to have a look at additional compounds down here. So similarity is another option. But here, what I wanted you to take on from this search was that SciFinder structure search would have 3 different structure matches: as drawn, substructure, and similarity. And if there is 0 as drawn, that means there is no exactly the same chemical structure compound and has no CAS registry number. So it's a new compound. And substructure means it has the drawings that I had in the CAS draw, but has additional substituents, and then the similarity as well. So these are some of the things, but I think we should have a look at what has been found. So instead, I am going to be adding this CAS registry number and enter and OK. But before we enter this, does anybody know what this compound is? Some may be familiar with this compound. Okay, let's have a look what this compound is. Click OK, search. Okay, so you can see now that there are as drawn substructure more compounds, 1,166 compounds, and then the first one that came out is caffeine. So the structure that I drew was a caffeine compound, and it comes out as the first compound because it has exact structure as I drew, plus the sorting is by relevance. But you can change the sorting to CAS registry number, molecular formula, molecular weight, the relevant number of references, and then the number of suppliers, depending on what you want to see. So, but why are there more than just one as drawn compounds? That is because as drawn structure match includes anything that has the same compound but has isotopes as well. So if you look at second, third, fourth, fifth, and sixth, all these compounds have deuterium. So the structure is exactly the same, but the molecular weight is different. So deuterium, tritium, or carbon-13, or any nitrogen-15, or anything would be included under as drawn. And number 12, if you look at this, this is a dimer. So it's not just one single compound, it's a dimer. Or any polymers or any mixtures or salt form, acid form compounds would fall under as drawn as well. Okay, so let's go to substructure, which is a lot bigger now, bigger answer set. Substructure includes the as drawn compounds. So it's basically as drawn plus actual other substructure compounds. But there are too many, and I want to narrow down substances that are maybe only relevant to my area of research, which is maybe natural compound or extraction or those area. Then what you can do, again, is there are 2 behaviors as we looked at, but I would recommend you look at this reference role. So what this reference role does is every compound in every reference has its role applied to it. So if this compound has been used as a drug in this in specific document, then it would have therapeutic use as a reference role. If you click on view, there are more available. So if you are looking for any compounds that had the pharmacological activity information, then this would be the selection for you. Or if there is anything that you think would be interesting, then maybe the analyte or natural product occurrence would be interesting. And also maybe biosynthetic preparation or any area that you think would really suit your research would be a very, very good way of using this. So reference role is another very good way of narrowing down the substances. But again, I think we don't really need any isotopes. So there's also an option down here, isotopes. I don't want any, so not containing isotopes. Let's just focus on any compounds that has no isotopes in it. And I don't think I need very big or very small compounds. So that means we can click on, sorry, there's so many. So molecular weight. So it looks like the range goes from 193 to 23,000, but I don't want this big. So maybe I'll do up to 300 as maximum. You can click apply. So all these filters are there. So you can start the search just like we did in the structure search. And then depending on what else you need to add, there are filters here. So we've looked at the reference role. We've looked at molecular weight, isotopes, and also there is substance class. If somebody is researching in polymeric or polymers, then there's polymer option. Or if you're interested in mixtures only, salt form, or organic and inorganic compounds, that will be your choice. So let's have a look at organic and small molecule. And then maybe a little more functional group. So we know in the structure that we drew, it had the alkene functional group, and additional things. But if you think there are things that you really want to be included in your thing, then I think I'm going to be adding halide in my structure. So you can use the functional group filter to halide, to apply, and see if any compound includes halide in it. So there's so many filters that you can use. And then maybe you can look at the experimental properties. So 77 compounds have melting point available. So you can narrow down to this as well. And yeah, if you need more details, you can click on the substance CAS registry number to take a look at information. So that would be additional way of finding substances. But instead of knowing all this very detailed information of a compound, like structure, CAS registry number, or compound name, you can also do a very general search, something like, I want flavonoids, or I only want alcohols, or I only want compounds that have carboxylic acid in it, or amide groups, or things like that. So you can do a very general substance type of a search. So flavonoids, because I started the search in the home page, you can see there is all search, with the substances being the first one. But you can click on substances or clicking on this to take a look at the whole answer set. So by doing the flavonoids as a substance name search, you can see very general flavonoids as search, substance name search, second one as well in the notes. But you can see 3 onwards. These are some of the examples of the flavonoids that you can probably find for under the flavonoids class of a compound. So this would be additional way of searching compounds for you. Okay, so now let's go back to the main page and use substance search. Reaction search. So I understand there aren't that many of you maybe doing organic synthesis, but I think this would be an interesting way of searching reaction. So instead of drawing the structure, you can type in this. So how to make primary alcohol from aldehyde. Very simple, very general, but let's have a look at it. So again, all but reaction comes out as the first result. So then there are also procedures available. So because we started the keyword search by doing how to make, so this system understands that you want to really know the procedure and experimental procedure of how the reaction works. So it really tells you the procedure. So number one, you would have to adjust something, you have to add something, you would have to do this and that. So that will be what it is providing in the front, on the front page. But if you click on view all reactions, not only that first one comes up, but there are other type of reactions that includes primary alcohol to be the product, and then aldehyde being the starting material. So you'll see there are a lot of different results coming out, and you can narrow down the searches on the left-hand side. Again, for the reactions, you can narrow down by yields. If you want the highest yield possible, you can click on 90 to 100. If you want to have a look at single step reactions only, there's a number of steps and experimental protocols. I actually think synthetic methods, experimental protocols is a very powerful way of looking at reactions, because most people who are looking at reactions are really looking to find the experimental procedure information and also maybe the final products analysis, like NMR spectra or IR mass spec, and maybe whether it's a white solid or yellow liquid or things like that. Those kind of information is provided under the synthetic methods. So now we're down to this number of results. If you click on any of these with the experimental protocols button available, but you would have to choose the scheme first, whether you're interested in this scheme or scheme 2, scheme 3, scheme 4. I'm actually quite interested in this scheme 5. So I want to click on, I'm going to look at the detail of this reaction. So clicking on experimental protocol gives you the detail of this reaction. So to be honest, I didn't click on the best example, but let's have a look. So this is the reaction scheme, meaning starting material, and then the product, yield, any suppliers if available, and then the steps information, and the reference information, which journal or patents this reaction is extracted from. This is what it means. Down here, there's experimental protocols. What the product is, reactant was, reagents, catalysts, solvents, and then the procedure. So number one, you should be using 50 ml stainless steel autoclave, blah, blah, blah. And then the transformation. So the reason why I said this is not the best example and to show you is because the final products analysis is not available for this particular reaction. So not everything will have that, but let's see, hopefully the number one or number two, let's see, this one wouldn't have it. Not really. It's okay. So it has the procedure, transformation, scale, and then the transformation information and reaction notes. So in this particular reaction, it had used high pressure, thermal, autoclave, and the conversion was 99.9, selectivity, blah, blah, blah. So all these type of very detailed reaction protocol is available if you choose to filter by synthetic methods. So this is one way of finding reactions. By drawing the structure, obviously, we'll do the same, but based on the reaction, the structure. Again, I'll be doing reaction search with the BR and nitrogen starting materials, and I want to create this. So I have just drawn 3 different compounds. Sorry, I think this is not really connected. Okay, so you'll have to make sure the bond is well connected. Okay, so I have drawn 3 different fragments of the compounds, and then I have used this arrow on the left-hand side to make sure which ones are the reactants and which one is the product. So I have drawn the arrow to make sure that these 2 are reactants and this is the product. So once you draw the structure, click OK, and it will do the search for you. So you don't have to go back to the main page. You can always do the search on the top of the page. Because the results that the page where we're at was reactions, it will automatically search under reactions. Plus, it's so obvious that this is a reaction search because we've done the arrow and then we set the reactants and products. So it's going to show you the results in reactions. So we see that there are, again, because we've done the structure search, as drawn, substructure, and similarity results came back. As drawn, 510 reactions. And for the scheme 1, there are 394 reactions. So what this means is they're using the same 2 of the same reactants to synthesize the specific substance. And then the scheme is the same, but the extracted references may be different, or even the reagents are different, yield are different, some reaction conditions are different. So even though they're using the same scheme, they may be using different conditions. So you can kind of compare which one would be the best one and see which one you should follow maybe later for your own reaction. If you want to have a look at all 394, click on View All Reaction Summaries. Then you will only see the 394 reactions for this particular reaction. Again, for second scheme, you can see there are deuteriums. So even for reactions under as drawn, deuterium, tritium, or any isotopes included compounds will be found. Let's go to substructure. There are now 1.6 million reactions, but not only that, you will see these compounds that have the structure included will be searched. So it's not exactly what it really does. So to make sure I'm not just looking at the structure similarity, I want to slightly change and modify the reaction a little bit. So I'm going to go back to the edit button right at the top. Click on edit drawing or the canvas. And I'm going to make sure where the reaction takes place. So on the left-hand side, maybe I will minimize the search box. So here on the left-hand side, the right at the bottom, there's this arrow with the 2 small lines drawn on it. So this is what it does is mark bonds to be formed or broken in a reaction search. Click on this and you can select specific bond to be broken in a reaction or to be formed in a reaction. So this will specify where the reaction takes place. Okay, and then you can also use this, map atoms in a reaction with a 1 and 1 with the arrow. If you click on this, you have to click on atom in the reactant and its corresponding atom in the product. So let's say I want this nitrogen in the reactant to be number 1, labeled number 1, and product, this nitrogen to be my nitrogen. So it has to be that. But in this particular reaction, it's quite obvious that this reaction takes place. But in a bigger reaction or in a very complicated reaction structures, making sure where the nitrogen goes, which bond breaks and which bond is formed will significantly narrow down the search results. And this one mark bonds to be formed or broken, you don't always have to use it in the reactant and product both. You can just use it in reactant or even product only, doesn't matter. So we can just do this and do the search. So let's have a look at the results now that we have chosen where the nitrogen goes, which bond breaks. Okay, as drawn, the number is exactly the same, but the substructure has gone down to 1.5 million. It used to be 1.6 million, if you remember. So it was a lot. It's now a lot smaller. And also the number is different right here. It's actually 1.3 million. The reason why it is that is because the reaction mapping filter has been automatically applied because of the fact that we've used the atom mapping and then the bond break option. So this filter has been automatically applied and now the result is a lot smaller. Yield, let's narrow down to the highest yield reactions. And also down here, I am only going to be looking at reactions where it uses palladium diacetate as my catalyst. So you can click on the catalyst and see which reactions used this particular catalyst. And then again down, more down, scroll down more, there's an option for you to choose the references, source references information. So if you click on document type, there are more patents this time than journal, but the ratio is similar. Language, English is the highest, but then there's Chinese, Japanese, German, Korean, and Russian in that order. Publication year and organization. Looks like Merck is taking the lead in this area. And Qingdao University and other universities around the world. But I want to narrow down the publication name. So clicking on publication name, it shows you mostly the title, the country names. It includes China, Japan, Korea. But I am mostly interested in Angewandte Chemie, organic letters, and ACS catalysts. So you can choose which journal you want the reactions from. So I have selected 3, click apply, and now the results are only extracted from the 3 journals that I have selected. There are around 200, just under 200 results. Okay, so if you're interested in looking at more of this and more details, click on experimental protocols or this reaction number. It goes to the same page. So we looked at it earlier on, but this is again, this is another way of coming back. So this is a good example again. I have selected a good one. So we've looked at the procedure earlier, but this one actually has additional characterization data. So for the final results, final product, the author has published proton NMR spectrum, carbon NMR spectrum, high resolution mass spec, and also the state. So all of this can be used for your own later reaction search. So let's go back. So reaction can be done like this. And maybe the final way of doing the reaction would be to type in named reaction, for example, Suzuki coupling. So you can do a Suzuki coupling reaction just by doing that. And later on, you can filter by additional things that we've just looked at. But searching by named reaction is another option, right? And then another option could be that you just give the SciFinder everything. So for example, I want to look at synthesis of catechin from compound I don't know, from compound, from methane, methanol, but used with catalyst, C, for example, with yield of 70 to 100% yield. So if you know, and if you want to find very specific reaction with all these details, then you have the option to do that by adding synthesis of final product from starting material with which catalyst and with what yield, what range of a yield that you want to look at. So all of these typing in would give you the final answer to the reaction. If nothing exists, you'll just see 0. Then you will have to change and modify a little bit of the keywords. Surely it will be a 0 results because this is not something it's going to happen. Anyways, we have this information there. Now you can see that the reaction was 0. It just gives you the references as the main search. Okay, so that's that. Let's go back to the substance detail. I think we looked at it earlier and it loaded now. So if you go into substance detail information early like this, you have the properties information, its other names. Instead of its catechin as its name, it has all these different synonyms. It's known as all these names, and then experimental properties being under biological, chemical, thermal information, structure related, and then experimental spectra if you're interested in proton NMR, carbon NMR, other heteroNMRs, etc. And pharmacological data, ADME, toxicity. If anybody is in more of the pharmaceutical area of research, this would be very useful. And we also have predicted properties and spectra, bioactivity indicators, where this catechin compound has been used and what type of bioactivity it has. And then targets, which proteins it's targeting, which enzymes, which cytokines, or which cell lines, etc. So all these things are very detailed, indexed for the specific compounds. And down here, there is regulatory information, which in the world, this compound has been approved to be used and where it's been listed and its hazard information. It looks like it causes serious eye irritation, may be harmful if swallowed, may cause respiratory irritation, etc., etc. So all these hazard information is also available in SciFinder. So we've looked at very, very detailed information. And maybe lastly, in SciFinder, I want you to look at this retrosynthesis. So instead of doing the reaction search, SciFinder has this retrosynthetic analysis function, which means it's really going backwards. We're adding the final targets and we're looking backwards to see what starting material or starting compounds we can start from. So in retrosynthetic analysis, it's doing very similar thing, but you can draw the structure first. It can either be a novel compound or a known compound. So SciFinder in retrosynthesis in SciFinder does both prediction and also experimental. So any compound that is unknown would be generated, and it will show you, it will suggest some of the routes, synthetic routes that you may be able to take for your research. But today, so today I will be doing a search with this compound. So bear with me, it might take a while to draw the structure, but shouldn't take too long. So I have checked this compound does not exist, just like we checked earlier with the other example of a compound. So this compound does not have CAS registry number. So 1, 2. And here it should have 5, and then here with double bond on this side with the nitrogen. Okay, so I want this compound to be created, and I want to target this compound. So once you're done drawing the structure, click Start Retrosynthetic Analysis on the right-hand side. And it's very simple, very simple. So on the right-hand side, there are 2 options, but it's optional. You don't always have to use this. Break bond. Which bond do you want it to break? As in, what do you want it to be the first disconnection? Meaning, in other words, which bond do you want to synthesize the last in the actual reaction? So you can choose the break bond option and say, okay, I want this bond to be the last one to be created in the actual reaction. And I want to protect this compound from the beginning, meaning I do not want to create this ring, fused ring, in the middle of a reaction. I just want to start from a reactant that contains this ring. So you can protect them, or you can just clear all. And then on the left-hand side, there are 3 options of prediction. So we've checked, well, I have checked that this compound is a non-existing new compound. So there will be 0 experimental results set. So to do that, to look at the 3 different predictions, there are 3 options. Number 1 is common rule. If you click on learn more, common rule means these reactions are commonly used in the lab. So you'll see very common reactions to be implemented in the retrosynthesis. But if you click on uncommon or rare rules, that means you will see a lot more options and you may be able to find more novel synthetic approaches. I am going to go with common. Click continue to retrosynthesis plan. And it will generate the retrosynthesis plan in probably less than a minute. So it was a very simple plan. So A is my target molecule. And you can see that these are all green, meaning these are all predicted steps. So there was nothing that was experimental. So it has been divided into B and C. You can basically start from B and C to create A. The average yield is 69%. And B is probably easy to buy because it's not very, very expensive and it's available. But C has no suppliers, so it has to be synthesized again. So it breaks down into D and E. So D is about 245 and E is 162 US dollars. So all these numbers are US dollars on the left-hand side, just like this. And if you think that this is still quite expensive, you can choose to change the starting material cost limit on the left-hand side. So I want my starting materials to be under 100 US dollars per mole. Then you can type it in and click apply and see if that creates a more suitable plan for you. Okay, now it's gone down to this plan. And now this one has blue line instead of green. So that means D, although this can be bought, but since this is more expensive than our set 100 US dollars, it has been broken down into these 3 fragments. And they are pretty cheap. So this one is methanol, and then this one is $22 per mole. So it has been gone down, and this is blue. That means it's an experimental step. So someone has already done this specific reaction. Okay, so all this plan has been created, but there's an option for you to navigate through a more customized option. So by clicking on these flasks, it opens up a flyer on the right. So C becoming D and E, meaning or D, E, and becoming C, has all these evidence, and there are additional 44 alternative steps. So if you click on alternative steps, this one you can replace to a different step as you wish. So the second one is the current step, but if you think other reactions are worth trying and taking a look, you can click on them and you can replace them. Now it has been replaced to this selected step. And some of these steps, especially the predicted steps, you should probably look at the evidence, because it's not experimental. It is really predicted, meaning there aren't exactly the same reaction, but there are very similar reactions that you can probably use in your reaction. So here there are how many reactions here. If you click on them, it should open up a new tab with the reactions why this reaction has been selected for your prediction. So the list of reactions that were used to suggest why this reaction has been used in this retrosynthesis. So all of this can be very simply done by drawing the structure and then running the retrosynthesis. And at the top of the page, there are yields and price calculated for every different plans. So this is just for you to take a look and maybe use to plan your own reaction. So overall price, so it's not too expensive. And then estimated yield 27%. But if you want to maybe increase the yield, you might want to change the plans by looking at looking at alternative steps. Okay, so when you're done, you can save them, and maybe you can just screen capture too. Let's go back to the main page. So we've looked at simple and very general things that you maybe use in SciFinder. But on if you click on App Switcher on the right, just on the left, just next to the homepage button, you have option to click on analytical methods, formulas as well. So I think analytical method would probably be the next most commonly used search for you guys. So what analytical method does is it searches specific analysis for your own analytes and also for any keywords or matrices that you're interested in. So it allows you to search by keywords, analytes, or any matrix. So today, as we have been doing a lot of different natural product search, you can type in any of things like that. So hibiscus, for example, is my keyword. But if you type in, you'll see a lot of different options down here. But if you don't see it, you can just type in more. Okay, so it looks like there is one. So if you click on it, it automatically gives it a double quotation mark, just so that it's a search by a phrase. If you press enter, it gives you everything that is about this keyword. So there are 49 results, and there are flavonoids as some of their analytes, some phenols, silver, fridolin, and then alkaloids, etc. But the matrix mainly is hibiscus that I typed in. But if you want to make sure the matrix is hibiscus, then you have to filter it down to this. Because all 49, it means it's not always from the matrix. It could be from the journal title as well. So I have made sure it's from a matrix, and then a method category. If you're interested in natural product isolation analysis, I think this is a good way of doing that. But if you want to look at others, just leave it open. Technique looks like solvent extraction and spectrophotometry these are the two main techniques that have been used for the specific matrix. Okay, maybe we'll just narrow it down to this. And what I want to see is the actual equipment that's been used and what are the procedures and how to make samples, all those details. So here on the right, the results came out. If you click on title, it takes you to the main detail of this specific analysis. Okay, so now we're inside. Here we have the title of the analysis of flavonoids in our matrix by what type of technique. Method number, analytes, matrix, material, and then the reagents. What kind of a compound that have been used for this specific analysis. On the left-hand side, the equipment used was spectrophotometer, instrument condition. The detection wavelength was 412 nanometers. And then the instruction, how the author has collected the flowers, and then how they did the extraction, what was the activity, and what was the actual final results of this reaction or the activity of this experiment. So all this type of information is not available in SciFinder. It's only available in analytical methods. So if any of you are interested in going deeper into more of the analysis part, then analytical method would be the best option for you to come. And again, on the left, there are source information. So this really takes you back to SciFinder. So SciFinder and analytical methods are linked. So you can go back to SciFinder from analytical methods or vice versa. So if you have been looking at some of the information in SciFinder, but if you see this button in the reference detail, view in CAS analytical methods, then click on it. Again, it takes you back to analytical methods. So it's connected very easily. So you can go back and forth from the between the two solutions. Okay, so we've done a very simple matrix search, but another thing would be for you to explore the method. So explore the method meaning you can click on the category first. If someone is interested in, for example, environmental analysis, and I'm also interested in pesticide residue analysis, and if there's any keywords or compounds that you are interested in to add in, then there's include keywords option. But this is optional, so you don't have to put anything in. So you can just view everything that is under pesticide residue analysis. Let's click on search methods. So pesticide residue, it can be very, the analysis could be done, the matrix can be done by, it can be in any fish, depending on where you want it to be, or it can be in any of the flowers and plants, or it can be in water, drinking water, river waters. But depending on where you want it to be, the matrix can be chosen. I am quite interested in fish, so I'm going to do that, fish as my matrix. And then technique, solid phase extraction is the most commonly used one. And then the validation. I want to have the precision information and limit of detection. Okay, now there are 99 results. So by looking at the title, you can get into this, but there are lots of different options again. Sort by relevance, or you can sort by publication year. There are type of a group. So some methods can be from the same document. So you can group by document as well. So if you choose to group by document, some document would have more than one methods. Well, it looks like this one, number 6, has 2 methods. Number 7 has 2 methods. Some might have more than just 2. So, okay, I am going to be expanding into number 10. So clicking on the third one, and it actually tells you, again, it has a very similar information, but this specific analysis has more detail, like equipment, which version of it, which brand was it, and then condition, what type of a column they used, the power, the preparation of a fish sample, and then the actual solution, extraction, and finally the validation information, recovery, precision, concentration. So anybody who is interested in analysis, this is definitely what you should come and do this. Going back to the previous page, I'm going to group by methods again. There are options for you to compare the methods. So if you click on compare, you can choose maximum of 3. So let's say I want to compare these 3 in a more tabular format, and click compare button and just underneath. Then it generates a table for you with the category, technique, analyte, matrix, other materials, equipment, preparation, and then instructions, detection, blah, blah, blah. So if there are very similar analysis methods that you want to compare, or very different ones to be included in one set of a reaction, the search results, then this is an option for you. And you can download it by PDF or Excel. Okay, so far we've looked at SciFinder, mainly the AI search function, AI summary, and then how you can navigate to substance information. And without going into the detail, you can have a look at proton NMRs, other type of properties information, and you can type in reaction type of a keyword and get to the reaction information. And again, retrosynthesis is also another type of an AI engine that's been implemented in SciFinder. So retrosynthesis prediction information has also been done. So anybody who is either looking for a novel synthetic routes or even different type of a reaction for a target molecule, retrosynthesis would be a place for you to go. And we also finally looked at the analytical methods, where you can search analysis depending on which matrix you are interested in, maybe the analyte, and also specific type of technique or equipment that you're interested in. So any keywords can be searched in analytical methods, and you can go back to SciFinder from here. So hopefully, so far for about an hour and a half that we covered, there's in the future, SciFinder and the details and information would be helpful for your research and your projects. Does anybody have any questions so far?
Anybody? You really have no questions? Those online, do you have questions? You really have no questions?
Okay, so I think someone is typing. So we might.
So who's typing?
Yeah.
It's up here. Okay. This is so useful for you, yeah? You can use SciFinder to find references for your practical lab report. Okay.
Yes, correct. So for any lab notes or practical, anything that is related to your research, you should definitely come to SciFinder first and see what has been researched in your field first. And then if there's anything that is useful for your actual your research, that will be perfect. But relevant area would be amazing. And also because now that we have AI summary information, if you type in a very general search keywords, it will just very simply summarize it for you with the reference. So again, when you're writing up your thesis or writing up your practical reports, then that might also be a very helpful resource for you.
And not only that, when you're given assignments, okay, especially on catalysis, anything that requires a lot of case studies and recent research works, you can always use SciFinder to find the references. Okay.
Yes, that is perfect.
So, any more questions? Anyone has any questions? You better have questions. Okay, you need to have a lot of practice using SciFinder, okay, so that it will be, this is so resourceful, okay, so please use this, maximize, optimize the use of SciFinder, okay, while you are in the university, please maximize the use of SciFinder, right? Okay, thank you so much, Ms. Josie.
Thank
By the way,
you.
where is Pamela?
Sorry?
Where is Pamela?
Pamela is on her business trip,
Oh,
and
okay.
I heard that this specific training was requested for this today and for this day, and she was not, she's probably flying currently. So yeah, she asked me if I was available, and I said I'd be happy to do this.
Yeah, thank you for spending your time with us. Okay,
Thank you so
so
much.
we hope to see you and Pamela next semester maybe.
Yep.
We both of you can come over.
Yeah, that'd be perfect.
Okay, all right. So with that, we give a round of applause to Ms. Josie. Thank you so much.
Thank you.
Okay, so I'll see you anytime. Okay.
Thank you so much. Thank
All right.
you.
Thank you. Bye bye. Bye all
Bye.
students.